of this stuff, you saw this when you took secondary 1. I'm going to go through and I'm going to show you how to solve this first warm-up problem in a very silly way, but it'll show you why people came up with what we call row operations. So today we're going to be doing row operations on 2x2 systems. So we're going to be solving systems of equations using row operations. Okay, so here's how I'm going to do this one. I'm going to blow this up one just a tad. Whoops, wrong way. Hit that, and there we go. So this is the way I'm going to do this problem. I'm going to do this one using elimination, but I'm going to keep track of certain things. So the first thing I'm going to do is I'm going to multiply this one by a -2, which gives me -2x and -6y, and this would be -10. Tell me if I make a mistake, because I'm still recovering from a bit of a cold. Now, I like this first equation, so I'm going to go ahead and write down 1x plus 3y equals 5, because I kind of like that equation. Don't argue, just kind of go along with it. These two, if I add these together, I get 0 x's, which I like because then I only have one variable. And this is going to be -7y, and if I put these two together, 3 minus 10 is going to be -7. Okay? Now, I really like this second equation because it only has a y in it. But I'd really like that to be a plain old y instead of a -7y. So what I'm going to do is I'm going to change colors here. And I'm going to take that equation and I'm going to multiply it by -1/7. If I multiply it by -1/7, it doesn't change this at all. So that's still a 0x. It does change this one. That changes to a 1y because I like it when I just have a plain old y. And then on the other side, I have a +1. Now, I haven't done anything with this one, but I'm going to keep this hanging around here. This is a 1x plus a 3y equals 5. And then what I'd really like to do is I'd really like to get rid of that y because I want to figure out what x is. Right now it's a 3y. So what I'm going to do is I'm going to take this equation right here and I'm going to multiply it by a -3. So if I multiply it by a -3, here's what I get. I've already made this a 0, so that doesn't change at all. This is just going to be a 0x. This is going to be a -3y. And this is going to be a -3. And like I said before, I kind of like this one right here because I have no x's. I have 1y, and I have a 1 over on the other side. So I can actually read off what the answer is for y right now. And now I can put the two of these together. And you'll notice because that's a 0x, if I add these together, it doesn't change it at all. This is a 1x. -3y plus 3y gives me a 0y. And then on the other side, I have a -3 plus a 5, and I end up with a 2. Okay? Now, I'm going to put a little box around this right here because there's a really nice thing that I've done. Yes, this is way too much work, and you would not do this on a normal basis. But what I've got here is I have 1x, no y's equals a 2. So that first equation literally just says that x is equal to 2. And that second equation, no x's and a y equals a 1, all it's saying is that y is equal to 1, so I've got the solution to the system. So 2, 1, there's the answer. I found the point where the lines cross. I kept track of everything in kind of a weird way, but I did it kind of in an organized fashion. I kept writing the x's every single time, I kept writing the y's every single time, and then I wrote the answers on the other side, and the equal sign was always in exactly the same place. So, you knew exactly where to look for the x's, you knew exactly where to look for the y's, and you knew exactly where to look for the answers on every single part of this. Okay? Now, raise your hand if that looks kind of familiar. A little bit? Okay. So, down on the next row, when we solve systems of equations, we do the same thing over and over and over again, and we write down the x's and y's a lot. Even here, when I wrote them down more than necessary, if you're solving using substitution or elimination, especially with elimination, we end up writing down the same things over and over and over again. So to save ourselves some time and some work, we can write them down as what we call an augmented matrix. So write the word augmented right there. And what an augmented matrix does is, because a matrix is an arrangement, a nice organized rectangular arrangement of numbers, it's going to keep track of things in columns and rows and keep them organized. And then we can use row operations in order to solve the system. So if I take this system, which we wrote up above, here's what the augmented system would look like. I put a square bracket. I do a 1, a 3, and a 5. And I do a 2, a -1, and a 3. And then I do a square bracket. And I can either do a solid line or a dotted line. You'll see both. Okay? This is the augmented matrix. So all I'm doing is I'm keeping track of the coefficients for x in the first column, the coefficients for y in the second column, and for lack of a better phrase, we're just going to call that the answer column at the end. Raise your hand if that looks kind of familiar. Great. So, somebody asked yesterday, when are we ever going to use this? We use this in our math classes. We use this to grow our brains. And we also use stuff like this. Not everything is exactly like this, but we use stuff like this to turn a problem that we have to go through the same types of things over and over again. We can hand it off to a computer and say, hey, I've organized all this. You go do the work for me. Okay? So if we can come up with algorithms and little systems of keeping things straight, we can tell a calculator how to do this, or a computer. So we're going to do row operations, and here are the row operations. There's 3 of them that we're going to work with. One of them is we can interchange any rows that we want. So we can take the first and second row and we can swap those. We call that a row swap. We can replace a row by a non-zero multiple of another row. So we can times a row by a number. I did a times a row by a number right here. When all I did is I just multiplied that second row by -1/7. And the thing that we do most often is we take a row and we replace it with a non-zero multiple of another row and we add it together, okay? So we're going to take a row, multiply it by something, and then add it to one of the rows that we're working with, okay? So we're going to do some shorthand for this, and I'm hoping this looks familiar, okay? We're going to use R1 and R2 to number the rows so we can keep them straight. So if I come up here, this would be R1 and this would be R2. If we switch the rows, we're just going to write the row 1 and row 2, and we're just going to put a double arrow between whichever ones we swap. If we multiply a row by a constant, we're just going to put that constant out in front. So this would mean we're going to multiply row 1 by 1/3. If we multiply row by a constant and add it to another one, let's say we're going to multiply by -2 and then we're going to add it to another one. This right here would be, say, take row 1, multiply it by -2, and then add it to row 2. Okay? And the thing that's important, put a star by this, it's the last row that's going to change. So if I write this down as my shorthand, R1 is not going to change, R2 is the one that's going to change. So we're just going to practice a couple of these. And again, what we're working on here is we're working on the part of our brain that can take a very simple command and then carry that out, even if it takes 6, 7, 8 operations, arithmetic or something like that, in order to get the answer. So we're going to do this right here. Now, if I brought a 7th grader in here and said, hey, we're going to do 1/3 times R3, their head would explode. Okay? But you being sophisticated enough, you know that this just means, hey, take 1/3 and multiply it by row 1. So row 2 is not going to change at all. So I like writing that down immediately and just leaving that how it is. Indeed. So our brain's on autopilot. Row 2 is not going to change at all. We're going to take 1/3 times row 1. So we do 1/3 times 3. That's a 1. 1/3 times -9. That's a -3. And 1/3 times -9. That's a -3. We just did that row operation. Okay, now I'm going to take this new matrix and I'm going to do this. I'm going to take -2 times row 1 and I'm going to add it to row 2. So I'm going to ask crew, which row does not change in this at all?
Row 2.
You want to try again? Which row does not change?
Does not, wait.
Which row does not change?
Row 2.
Nope. You want to try again?
What did he say like a while ago?
Row 1.
Thanks, it's row 1. Row 1 is not going to change. In the end result of this, row 1 is not going to change. It's always the second one that's going to change. So row 1 is going to be 1, -3, and -3, and I'm going to write the line right here. Now, the way we get the new row 2 is we carry out this little command. So I am going to have to do a little bit of work off to the side or something. I'm going to take row 1 and I'm going to multiply it by -2. So if I multiply by -2, and I'm going to put it down here if that's okay, -2, multiplied by -2, that's going to be a 6. Multiplied by -2, that's going to be a 6. Okay, now I'm going to take this multiple of row 1 and I'm going to add it to row 2. So 2 minus 2, 0. -5 plus 6, that's a 1. -4 plus 6, that's a 2. Everybody good there?
Yep.
Okay,
Yeah.
so row 1 did not change. We left that alone. We used a copy, a multiple of row 1 in order to change row 2. Row 2 is the one that changed. Fellas, you doing okay back there? We good? Okay. Now we're going to do this one right here. I'm going to come back to crew. Crew, which one is not going to change on this one?
Row 2.
Row 2, very good. I'm comfortable with row 2. I like it. I'm going to leave it there. So this is 0, 1, 2. The one that is going to change is row 1. I'm going to use a multiple of row 2, 3 times row 2, and I'm going to add it to row 1. So I'm going to take row 2 and I'm going to multiply it by 3. So that's going to be 0, 3, and 6. And then I'm going to add these two together. So 1 plus 0 is 1. -3 plus 3 is 0. -3 plus 6 is 3.
That's the answer.
That is the answer. Now, if you take a look here, you'll notice something. We started off with this one, and I did this row operation, and I got this. That's the same one, isn't it? Then I did this row operation, and I got this. Then I did this row operation, and I got this. This is the answer right here. This says that x is equal to 3 and y is equal to 2. So if we wrote that as an ordered pair, they would cross at 3, 2. We weren't even thinking about lines. We weren't really thinking about x's and y's. We were just kind of playing a game here and making this look like this.
That would be easier.
Okay? This happens to be called reduced row echelon form. This right here is called an identity matrix. When you have ones
Called
down,
what?
we'll get to that again. As a name, it's called reduced row echelon form. When we have ones down the diagonals and 0 everywhere else, that's called an identity matrix. And over here, we just have the answers. So we get an answer for x right here, and we get an answer for y right there. Okay, everybody good? Raise your hand if you've seen this before. Okay. Okay, watch please. Hold on, don't flip it over. Okay, if you can, this can get really frustrating because we're going to be doing these by hand for the most part to start with. You want to get the goals in this order. You want to get that 1 first. Then you want to use that 1 to make that a 0, so that's goal number 2. Goal number 3 is to make that a 1, so you do that one third. And then if you can, you do this one fourth. So the way we say this is we go column by column, get the 1s first, and then use the 1s to make the 0s in that column. So goal number 1 is to get a 1 right here. Goal number 2 is to use that 1 to make that a 0. Goal number 3 is to turn this one into a 1, and then goal number 4 is to use that 1 to make that a 0. And we should be able to read off the answers on the other side. Okay, any questions there? Okay, now flip it over.
You should let us do these by yourself.
I'll let you do one by yourself, but hang on. Okay, some tips to avoid frustration. And get the correct answer, because we always like that. Go slowly. If you go too fast and make a mistake, it's going to be really frustrating. Next thing is keep things neat and aligned. I have really crappy penmanship, but when I'm doing these, I try and keep everything nice and neat and in order. If you can avoid fractions, do it, but sometimes it's unavoidable. And here's the important one. Go column by column, get the 1 first, and then use the 1s to make the 0s. So get the 1s first, use the 1s to make the 0s. Get the goals in order. Again, this is first, this is second, this is third, and this is fourth. So get the 1, use it to make the 0. Get the 1, use it to make the 0. Okay, and then don't forget to write the answer as an ordered pair, because ultimately what we're trying to do is, instead of graphing using substitution or elimination to find a point where the lines cross, we're using something called an augmented matrix and row operations. Okay, so Wilson.
I could be doing augmented Fortnite instead of this.
Wilson, what would you do first on this one if our goal is to get a 1 right there?
1/2 row 1.
Okay, hold on. Listen up. Wilson says we could do 1/2 times row 1. Could we do that?
Wait.
Absolutely.
Let's-
Cash. Or sorry, Psi. I've got cash in my other class.
Cash min.
2 times R2 plus 1.
We could do -1 times R2, add it to R1. There's a super easy way to turn it into a 1. Yeah.
Can we just swap them?
Sure, we're going to do this. We're going to do row 1 swapped with row 2, so let's do that.
I want to. You get the same answer.
You do.
Row 2 times negative.
Silly
Okay.
Wilson.
Now I've got goal number 1 taken care of. I want to turn that into a 0. So what do I add to 2 to turn it into a 0? So write down that number that you just said. I'm going to say this over and over again. What do we add to 2 to make it a 0? -2. So that's the number you multiply. So we're going to multiply row 1 by -2, and we're going to add it to row 2. Crew, which row is going to change here?
What one's gonna change?
Yep,
Row 2.
row 2. So
Yeah.
row 1 stays the same, so I'm going to write down a 1, a 3, and a 5. And now I'm going to do -2 times row 1. So that's -2, -6, -10. Let's add that multiple of row 1 to row 2. So I'm going to end up with a 0, a -7, and a -7.
Yes.
You need that little line there, though.
I have a question.
I always forget that little line, so thanks for reminding me. Yeah.
Gotcha.
Does it matter what side you write, like what you did on? Like,
Oh, this side or that side?
Yeah.
No, it doesn't matter.
Okay.
I just like writing it over here. Okay. What's the easiest way to turn that into a 1?
divide 8.
Keely.
Oh, just kidding. Hold on, sorry.
Got it.
You want to turn that into a 1?
Divide by -7.
Okay, divide by -7, or we're always going to multiply it by something, so we're going to multiply by 1/7. So this is going to be -1/7 times row 2. Crew, what row is going to change?
Row 1.
Oh my
Oh my gosh.
Rental.
You want to try again?
Row 2.
Row 2 is going to change.
True.
I've got
I feel
3 of the
bad for
4
you.
goals taken
Jack,
care
take my
of.
pencil.
Listen
no.
up,
You
please.
just dropped it.
Okay, we're wasting time. I've got 3 of the 4 goals taken care of. Do not answer this question out loud. I just want you to think. I need to turn that 3 into a 0. Don't answer out loud. What do I add to 3 to turn it into a 0? Andy, what do I add to 3 to turn it into a 0?
-3.
Very good. -3 times the row with the 1 in it. That's row 2. And we're going to add to row 1. So I'd ask cash, but crew, but that would take a while. Row 1 is going to change. Row 2 stays the same. So 0, 1, 1.
This is so.
And I'm going to use a multiple of this row. So I'm going to multiply by -3. 0, -3, and -3. If I add the 1 and the 0, I end up with a 1. If I add the 3 and the -3, I end up with a 0. And if I add the 5 and the -3, I end up with a 2. So this is the right answer. We've done all the row operations. All we want to do is write it as an ordered pair, 2, 1.
Okay, but you flipped them. Why does it 2, 1 when you flipped
Example
it?
3.
'Cause what if-
Kind of
Never mind.
Got it? Okay. Any questions? Yeah.
Does it matter like how you write the order together, like you did 2, 1 or 1, 2?
It does, because this one right here, this is a great question Keely just asked. Does it matter what order you write them? This is the X column, this is the Y column, and this is the answer column. So this first equation means we have one X and it equals 2. And that second equation says we have 1Y and it equals 1. So X is equal to 2 and Y is equal to 1. So it doesn't matter. Everybody good?
That was my question.
Okay, raise your hand if that looked familiar. Okay, I'm hoping that looked familiar because you probably saw it last year, and if you look at the warm-up question, isn't that the same as the warm-up question?
Yeah,
No.
You'll find exactly the same steps in there.
Do it, that's why.
Okay. All right, flip
But
the
we
page
didn't,
over.
we didn't do the flip on the warm-up.
We didn't do the flip. You're right. Okay, everybody take a look here.
Right, this is an
Oh
augmented
my
matrix.
goodness.
I know elimination.
I don't want.
Right? This
I
one.
know elimination.
Yeah, we are going to write them as an augmented matrix as soon as I've got everybody's attention. Okay. We are going to occasionally run into fractions. Let's not panic about that. If I were going to do this one right here, here's the first thing I would do. I wouldn't write it like this. The first thing I would do is I would just automatically switch them because I like the fact that that has a 1. So I would write a 1, a 1/2, and a 4, a 2, a 4, and an 8, and put the line right there. Saves us a step, saves us one whole matrix of writing.
Would you still have to write down like row flip or no?
No. I mean, if you wanted to do row 1, double arrow, row 2, that'd be fine with me. But most people would be able to see that.
Now we have to time for
Okay. Don't answer out loud. I'm going to call on somebody. I've got a 1 here. I need to use that 1 to turn that into a 0. So Samara, what do I add to 2 to make it a 0?
-2.
Very good. So we're going to do a -2 times the row with the 1 in it. So that's row 1, and we're going to add it to row 2. Row 1 gets to stay the same. We like the way that looked. That's going to be a 1, a 1/2, and a 4. I'm going to multiply by a -2. That's going to be -2. That's going to be a -1, and that's going to be a -8. Then I'm going to add these together. So -2 and 2, that makes a 0. We like that. -1 and 4, that makes a 3. I'm okay with that. And then 0.
Dude, no
Yep.
way.
We're multiplying by 2, not by half.
Come on, Jack.
Yeah, Jack.
Okay, Angela, what's the easiest way to turn that 3 into a 1?
2/3
Perfect. 1/3 times row 2. Row 2 is going to change. Row 1 gets to stay the same. So this is a 1/2. This is a 4. Multiply by 1/3. That's a 0. So it's still 0. Multiply by 1/3. So that's a 1. And that's going to be a 0. Okay, Luke. What do I add to 1/2 to make it a 0?
-1/2.
-1/2 is the number we're going to multiply by. And we're going to multiply the second row because that's got the 1 in it. And we're going to add it to row 1. So the row that doesn't change is row 2. So it gets to stay just exactly like it was. We like the way that looked. We're going to multiply that second row by -1/2. So this is a 0, a -1/2, and a 0. So this is going to be a 1. So I do 0 plus 1. -1/2 plus 1/2 is a 0. And this is a 4.
Wow, Jack.
So, Caleb, what's the answer here? 4, 0. Circle that, we're done. Okay, are there any questions?
This is rad.
I love this.
Okay, is this very hard?
No.
Okay, it does give your brain a workout. We're keeping track of a whole bunch of arithmetic. Okay, let's take a look at the next one.
Wiki indicates is the best one.
Augmented matrix to start with. There's no quick getting around this or anything. This is a 10, a -2, and a 6. A -5, a 1, and a -3. Dane, what are we going to do to make that a 1?
Times it by 1.
1/10 times R1.
That's garbage.
So 1, let's see, 2/10 would be 1/5, so that's -1/5. 6/10 would be 3/5, so we got some fractions to deal with. But at least we can put our brain on autopilot and we can just write down the second row.
I got a quick question.
Hang on, Keely?
You forgot the little one.
I did forget the little line.
Why do you
Yeah.
hate the little
So, like, do you always have to like solve for that one first, or could you like solve for like the 0 over there, and then like
If you wanted to go in any willy-nilly order you wanted to, you could. It's just if you don't do it in a systematic fashion, you're going to end up undoing work that you already did, and it's going to get really frustrating. Okay?
Alright, I know that's the part.
Okay, Zach, what do I add to a -5 to make it a 0?
5.
A 5. So we're going to take a 5 and we're going to multiply it by the row with the 1 in it, which happens to be row 1, and we're going to add it to row 2. So the row that's not going to change is the first row. So that's a 1, a -1/5, and a 3/5. Thanks for reminding me about the line. I'm going to multiply row 1 by a 5, so I get a 5, a -1, and a +3. 5 and -5 make a 0. -1 and 1 make a 0. 3 and -3 make a 0. Do not say anything out loud. Who can raise their hand and tell us what that means?
Means 0 equals 0.
It does mean 0 equals 0. What does that mean?
I kind of. Isn't it like no solution or something like that?
Opposite of no solution.
Oh, infinitely solution.
Okay, this means infinitely many solutions.
Okay. Hold on. What did you just do?
Infinitely many solutions. And the reason for this is that last equation means that 0 equals 0. Well, no duh. 0 equals 0. There's nothing you can do to make that false.
Sure.
So this is going to be a true system. It's not. This is going to be a true system. Here's what happens with that. When we're graphing lines and we get infinitely many solutions, these are basically copies of the same line. If you look really carefully at the beginning, one is a constant multiple of the other. If you took the top one and divided by -2, you'd get the bottom one. Okay? Or you could say the top one is twice as much and negative of the second one. These are the same lines, so they cross in infinitely many points. Yeah.
Is there anything like? Because I can't remember from last year. Isn't there something that makes it like no solution?
There are some that are no solution. So let's talk about that right now.
Isn't that when
What would happen if we ended up with 0, not 0 over here? What could it be so it's no solution?
4?
8.
Yeah, any number other than 0. So if we put and I'm going to change colors, if I put a -3 here, this would say 0 equals -3. There's no way 0 can equal -3, so that would be no solution.
What if we
Okay?
did 0.1?
Then they would just be like parallel and like.
I'll do 0.1 because that's 0.1.
Okay, Wilson.
Yeah.
Everybody set up C.
I've already
set
did
up.
it.
Everybody set up C.
Silly me.
Gotta solve for that one.
Oh, you have to solve for what? I want to read chocolate.
Wait, what?
Oh.
What? What is that wrong? Like going crazy.
Wilson, what do you have to do first?
Simplify the bottom one.
How would you do that?
You would you'd switch sides on the 1 and the y.
Okay, so you're going to move this over here.
Or you could just do the 5.
Just
over 2x.
just move that over.
Yeah,
Okay, do that by subtracting, right?
I guess.
Okay. So this would be 5x minus 2y equals -7. And this would be -5/2 x plus y equals 1, right?
Yeah.
Okay. Does anybody see a way that we can get out of those fractions?
No. Multiplying by 5. Not 2.
Okay. I mean, you could write this down: 5, -2, and -7, and then -5/2 and 1 and 1. That would work just fine.
Nice job.
Does anybody see how we could get rid of the fractions on the second one? Yeah,
Since when you do it, the top is 5 and 2.
kind of.
Row 1 times row 2.
Luke,
Why don't you just multiply the bottom one by 2?
could we multiply the bottom one by 2?
Yes.
Yeah, we could. Okay. Now, in this particular case, it's not worth it, and here's why. I want to turn that into a 1. So we're going to do 1/5 times row 1. So that's going to be a 1. That's going to be a -2/5. And that's going to be a -7/5. And this is going to be a -5/2. This is going to be a 1, and that's going to be a 1. And I'm going to zoom in just a tad.
I see.
Now we gotta make
Because
zero.
now you
Okay, crew, What do I add to negative 5 halves to make it a 0?
You add 5 halves.
I add 5 halves. So we just came up with the number we're going to multiply by. So we're going to do 5 halves times row 1, and we're going to add it to row 2. Would you do that, please, and figure out what the answer is to this? Do not say anything out loud. I want it quiet for about the next 2 minutes. Do not say anything. Figure out the rest of this problem. Don't say anything out loud. That includes you.
I just said do.
You could just do it and get the answer. Can you give us like a long skips? Because this stuff is so lame and takes forever.
It's so lame and takes forever.
So easy.
It takes forever.
Yeah, I know it takes forever, but it's
Okay. You're welcome to double check me. Did you get this? Okay. Don't say anything out loud. I said I still wanted it quiet. Keely, if this is 0, 0, and negative 5 halves, what does that mean about the system?
No solution.
That means no solution. Would you raise your hand if you got no solution? Okay. Do you have any questions?
Why wouldn't it be 7 over 2?